Welcome back to Real Garage. I'm Andy Weinberg and I'm joined by Mark McDonald. Mark is a lead fabricator at Detroit Speed and Engineering, and he's going to help me with this part of the roll cage install. He has tons of first-gen Camaro and Firebird experience, and I'm super stoked to have his help. Originally, I was going to build a top halo bar and A-post for this, but after talking with Mark, I think he has a better idea. Tell me what you're thinking.
So yeah, traditionally you'd see a halo bar in the roof of the car, followed by A-pillar bars that meet to it. Well, those are kind of intrusive to the driver because you can't get it up into the roof far enough and get a good fitment. So what we do at Detroit Speed, and I prefer, is A-pillar bars all the way up and back to the main hoop with a windshield bar that tucks in tightly to the roof. Okay. It gives you a lot of headroom and visual through the front windshield.
Perfect. Why don't you show me how you do it?
Yeah, sure, come on. All right, let's see what we got here.
All right, where do you start?
All right, so start off with a piece of tubing, same diameter as the roll bar tubing you're going to use. I cut this at an angle, so it sits on the top of the dash, and you can see it stays inside the windshield bed. You have a piece of aluminum that you've made to emulate the windshield, or make sure you're not into it. So you can see it's got plenty of clearance there. So what you do, you stick it up here, scribe around it or Sharpie it. You can see Andy's already done these steps, trimmed out the dash. Well, also, when you're done, you'll trim this all the way down and get rid of this, save it for later. What this does, it gives you access to get the bar that's got multiple bends in place and gives you a good access to weld the dash bar in completely. Andy's also went ahead and installed the lower gusset plates in the floor that'll give us a target for our A-pillar bar to be installed too. Next, I'll show you guys the procedures I use to get a properly fit and bent bar.
Perfect.
All right, Andy, so I always use a piece of 3/16 brake line tubing. What I'll do is I'll bend this to the shape of the bar where I want it to lay, and keep in mind I'm working off center of the tubing. Okay. So 3/16 brake line bends real easy. It's easy to get at the parts store. You know, just kind of manipulate it into the car. Let's hit our target down there. It comes through the dash, about center. Looks good coming through here. All right, cool. All right, and I'll show you how I transfer all of these bends into measurements and to the tube.
Okay, excellent.
All right, Andy, let's lay these bends out and transfer all the measurements to the tube.
All right.
You got something right on, help me keep up with the measurements so we can reference those later. All right, first bend is going to start at 23 3/4. All right, and I got a homemade protractor here. So basically this protractor has the same bend radius as our tubing bender. You can see I've marked inch increments on here, so that'll help us lay out our bend on our piece of tubing. So basically using it like a gauge. All right. All right, 4 7/8. And basically that's where the tubing goes straight again. So that measurement is used to measure to the next bend. So to the straight section of this is 15 1/2. And again, like I said before, we're working off of tube center line. All right, 5 1/8.
5 1/8?
Yep. 19 3/4, and that's the start of our last bend. All right, and I'll get this piece of tubing on here to weight this down so it's not fussing with us. All right, 2 inches. Cool. All right, and we'll measure the length of this and add a couple inches to it, so to give us some buffer to make sure we don't cut it too short. Let's see what we got. All right, that gives us 75 1/4. Let's go 78. That way we have a couple inches to tune this thing in with.
Perfect.
All right, Andy, let's lay all these bends out. Let's get your notes and.
All right, here, I'll hold the dumb end.
All right. What's our first measurement?
23 3/4.
23 3/4. All right, and what I'll do there is I'll put a mark and I'll put an S on it because that's our start bend. All right, and then what's our next measurement?
4 7/8.
All right, 4 7/8. All right, then what's after that?
15 1/2.
Come on, good. 15 1/2, and that's a start bend.
5 1/8.
All right, and then our last
19 3/4.
19 3/4.
And then there's a 2 inch at the end.
All right, yeah, this right here is not crucial, but anyway, that one's not. It's just a reference. Cool.
All right, to the bender we go.
That's right. So this bender's got a start position right at the edge of the eye. It lines up with the Sharpie mark we put with the S on it, so that's where the start of our bend will be. All right, and I have my protractor set for the first bend, which was 4 7/8. So. That's cool. Now, all tubing has a little spring back. This type of tubing Andy's using, Docall, isn't that right, Andy?
Yep.
Yeah, so it's got a little more spring back in it too, kind of more like chromoly. So we'll have to, I'm gonna let the pressure off the bender. Done. All right, gotta go a little bit more. All right, Andy, so we got our first bend done in our tube. We need to figure out our clocking for the second bend. So we'll take and lay this on the table here. We got our angle finder. Let's take the angle finder on here. We'll zero it. We'll have to just barely rest it on there. 27 degrees. Here, write that down. Same thing, we line that up on our mark that we put the S on against the die. So that's the start of our bend. I'm gonna put a little pressure on it so it stays and then we're gonna clock this 27 degrees. Now what I do is take our template just to make sure that we are orienting these bends right. All right, cool. So, all right, then we'll go 27 degrees up. I'll set the protractor to 5 1/8. It's pretty good down there. Got a little gap, put the filler wire in. Cut a little off of that. Not too cool. Andy, I think that's it.
Yeah, it's pretty tight. So basically it's rinse and repeat for the other side.
Correct.
Yeah, except it's a mirror image.
Yep. It's usually harder.
Yeah, okay, so while you're doing that, I will make the lower rocker bar for this side, and you guys can check out a real scoop on plasma cutting guides. Today's real scoop is about plasma cutting. Now, I don't care how straight your line is drawn. If you aren't perfectly smooth at moving that torch, it's gonna cut crooked. It's like a little laser. Any little hiccup in your freehand is gonna be cut into the piece of metal that you're working with. So for me, I like to use cutting guides. Now, I've built a few of these over the years, but I prefer to use something that's non-conductive. Now, I usually will take this, set it on my piece that I'm working with, and then line up the tip of the plasma torch to the line that I had drawn. Okay? However, I found that it's kind of difficult to hold my cutting guide and follow it along with my torch, especially if I'm cutting over a longer distance. So what I've done is take these cutting guides and I've put magnets in them. I basically just went out and got some of that strip magnets that has the adhesive on one side, and that's now what I use for my cutting guides. Now, ideally, this is a non-conductive material. I'm using Delrin. It's a high-strength plastic type material. It's also high temperature. I like it because it's non-conductive. When working with a drag shield, that's really not much of a problem. You could use another piece of metal and drag it along it. However, when you take the drag shield off and just use an open tip with the deflector shield, okay, now if you're using a piece of conductive material like a angle iron or just another piece of metal, you're running the edge of the tip along that piece of metal. The tip is conductive and it's conducting that plasma stream. If you're running against another piece of metal, it causes the plasma flow to come out crooked out of the tip and it wears the tip out faster. So that's one of the reasons I like to use this non-conductive material. Now, the plasma stream itself is extremely high temperature, but the heat effect zone caused by the plasma stream is very narrow. Now that temperature will never be seen by the Delrin, so it doesn't even melt. Okay? The ideal thickness of one of these plasma guides would be about 1/4 inch thick. Okay? That gets it high enough on the tip where you're past the chamfered part of the tip. Okay? You're on the flat edge of the tip. So this is a much better way to make straight lines. And remember, read and follow all labels and your owner's manuals. I can just set it down on the piece. I line up my tip with my line and pull the trigger. And I got a perfectly straight cut. My next piece of advice is for cutting radiuses. I like to use a narrow hose clamp and a piece of high strength string. And what I do is I clamp that right to the deflector ring, perpendicular to my plasma torch. Okay. Now what that does for me is it makes it easy for me to cut radiuses by simply measuring how far from the tip along the string I want my radius to be cut. Now I don't really need any special cutting guides or anything for this. It's simply a piece of string and measure how far you want your radius and then cut. Now the key to doing this and making sure your radius is consistent is to make sure that your plasma torch stays perpendicular to the string as you're making that cut. So if I want to basically make a 3-inch radius cut on the end of this piece, I'm just going to measure 3 inches starting from where I want my starting point on my sheet, but I'm going to make that starting point halfway on my material. So this material is 4.5 inches. So 2.5 inch or 2 1/4 inches in by 3 inches is where I need to make my basic pivot point. Now I take my plasma gun, take my plasma torch, start it at the edge, make a dry run, make sure I have all the clearance that I need. And make a perfect 3-inch radius. When piercing material, because you're not starting on an edge, you're going to want to take your plasma torch and cant it at an angle so that the back blast of the plasma stream doesn't foul up the tip. This allows you to pierce through the material. Once you get pierced through the material, then position your plasma torch back to 90 degrees to the piece and continue to cut out the shapes.
All right, Andy, so you got all the tubes tacked in place. Yep. Coming down to the windshield bar, we'll determine where you want that, a good visual for you. And like I said, again, one of the reasons I like running a windshield bar versus a halo, we'll take this piece of mock-up tube and you can position this thing several different places and kind of look through the front of the car, back through the car, and get a good idea where you want the bar. Mm-hmm. And we can go ahead and start trying to figure this out. So let me know what you think. Where would look the best for you? I know you're a little taller, seat,
about
so
6 feet, but
all right. So right there would be right in the windshield.
Yeah, it would be a little bit low. I mean, although we do kind of have that sun guard here a little bit, but.
And one thing you got to look at too, being able to weld the top of this.
Yeah.
So.
Is it possible to cant this at a little bit of an angle? And
Yeah,
kind of
I can put a little bend here, and then we'll do offset notch, and I'll put the bar up into the roof, and it doesn't hinder your view through the windshield at all, and you'll be able to weld all the way around that.
Yeah, I think that'd be ideal. Because if you put it back farther, it's pretty tight up to here.
Yep.
Yeah, I think the best thing to do would be come out here, cant it up at an angle, and just run it tight.
All right, well, I'll put a mark here. The center of the tube, and we'll get a rough measurement, and I'll add a few inches to the bar, and I'll put some bends in it. See if I can reach across there. It shows 41, so let's cut it 44 inches. That'll give us plenty of room to dial this thing in. Cool. Yeah. All right, so we got our tube cut for the windshield bar, and something I did similar to the brake line tube, I took a piece of filler rod and I bent it to the bend radius that I'm anticipating for the bar to be up into the roof of the car. So done the same thing, transferred it over to the protractor I made, and just going to use this, being there's only 2 bends and they're just going to be on a flat plane. I don't have to worry about clocking stuff. So like I said, I use this to get my bend radius where I want it. All right, we got it bent. Next thing we're gonna do is start marking this thing and dialing it in for our notches and get it fit to the car. All right, so I've got the bar marked out where I want it fit, coat, leveled, squared in the car. One side clamped in place. I'm gonna put a clamp on this side and call Andy over here and see if he's okay with the fitment. What do you think?
Oh, hell yeah. That's perfect.
Nice. Well, shoot, man, suit up and throw some tacks on this thing. We'll move on to the dash bar.
All right.
Cool.
Let's get her done.
Yeah. All right, Andy, I got the dash bar notch fit in place. Fits pretty good.
It's perfect. Yeah, actually, I'll tack that in place and then I'll go back to welding in my rocker bars and then finish welding the tubes in.
Yeah, and jump around as you go, of course.
Oh yeah, definitely jump around. I really only weld about 1/3 of the way around each tube.
Yeah.
Because that way I let it cool, and then when I come back to it and start welding on again, it won't pull.
Yeah, especially when you get a cage that's fitting really tight. While we have everything here, if you over weld a joint, it could pull and you'll never get it back.
Yeah, it screws up the other one.
Sure does.
Hey, well, thank you very much for your time.
Anytime.
It was a big help.
I'm glad I could be help.
And yeah, I guess I'll let you get out of here.
Let's get some food.
Food? Let's get some beer.
That sounds good too.
For making my lower rocker bars, I start off by basically determining how high this is going to be. Usually I go 1 tubing length off the base, so I'm going to be about 1.5 inches to 1.5 inches up. Then I'll take and measure from the center of my forward tube to the center of this one to give my rough overall length, which this is going to be 49.5. And because I have these canted at 2 different angles, I need to determine that. So if your project is level, you can simply just use an angle finder and figure out that angle, or just get yourself a protractor and set it on there, and you can easily determine that. Now I know this tube is about 85.5 degrees, and the protractor is actually saying 6. So I'll cut it at 6. And on the forward one, this one is going to be almost 20 degrees. So those are going to be my 2 cuts for my coping of the tubing. All right, I got my rocker tube at the same angle as the frame of the car. So I'm just going to tack this in place. And all right, now that I got my bars all tacked in place, I can take my time welding it up. Join us next time on Real Garage when we try to figure out how we're going to get our fuel in the fuel cell from the outside of the quarter panel.